What's up? Mr. Allen here. We're going to find the area of a square that has a diagonal of length 30 meters. First thing I'm going to do is I'm going to pop down a square for my diagram. Boom. Look at that perfect square. Every time, baby. Every time. All right. So my diagonal is going to be 30 meters. So if I throw down a diagonal here from end to end, that looks pretty good to me. Whoop. All right. Boom. There we go. That's 30 meters. What can I do with that? Maybe make a better zero. That's a little better. All right. What can I do with that here? Well, I know that I have right angles, right? It's a square. So I got 4 right angles. I'm just going to mark the 1. My diagonals also bisect the angles. So that would make these guys 45 and 45. Same with this one right here. Oh my goodness, I have a 45, 45, 90 triangle. Well, if I have a 45, 45, 90 triangle, couldn't I solve for the sides of that square? They're all going to be the same, right? Well, how do I get from the hypotenuse of a 45, 45, 90 triangle to the leg? Well, I would divide by the square root of 2. So let's do that. 30 divided by the square root of 2. I'm going to rationalize that because for whatever reason, we don't like square roots in the denominator. I still don't know that. No one knows that. We just keep doing it blindly. I don't know why. I need to change that. We need a revolution on rationalizing denominators. All right, I'm just going to keep it there. No, I'm not. I'm going to keep following the rules. Okay, so 30 divided by 2 is 15 root 2. So that's my side length right there. And I know that the area of a square is either base times height or side times side, however you want to look at it. Side squared, so 15 root 2 squared. My area is going to be 15 root 2 times 15 root 2, or 15 root 2 squared. So I'm going to get 225 times 2, which is going to be 450, and we've got meters squared. Boom. There is my area. Now you might be thinking to yourself, is there another way? Because that was kind of a lot of work, wasn't it? There is another way. Are you ready for it? Now I was given the diagonal of 30 meters, right? And I know that my diagonals of a square are congruent. So the other one is also going to end up being 30 meters as well. And what do I know about my diagonals of a square? They are perpendicular. It follows those properties of a rhombus, right? But the congruent diagonals is a property of rectangles. But in any event here, my diagonals are both 30 and 30. So diagonal 1 is 30 and diagonal 2 is also 30. Since my diagonals are perpendicular, I can use that area formula from a rhombus or a kite or anything with perpendicular diagonals. Area is equal to diagonal 1 times diagonal 2 divided by 2. And if I do 30 times 30 divided by 2, I end up getting 900 divided by 2, which is, drum roll please, 450 meters squared. Exactly what I got before. That is dope. Either way you slice, you can get that same area. Your call. If you think, hey man, I got diagonals, I can use that formula. And if you remember that formula, that's awesome. If you go about it like we did with the 45, 45, 90 triangles, that's cool too. They both work. I love when we got 2 ways of doing things. It's like double the fun.